Now, for the same question that we had earlier, this one, right, 2x squared plus 1, right, at 3 comma 19, and we know the fact that this is equal to 12. We know, okay, because we learned that f prime of x is 4x, so f prime of 3 is equal to 12. Now, so I'm going to use this example to extend our understanding of derivative a little bit, because not only we have the derivative of the definition of the derivative, we also have something called the alternate definition. Now, what is the difference between the definition and the alternate definition? I would say there are two layers of difference, but minor. Well, I would say minor for the most part. I'm sorry. Still have 2 points. But now the way we label them is slightly different. Okay. This is going to be my x and f of x. Okay. And what about the other point? Now, the other point, at this very moment, I am going to label this c, which is supposed to be a known value. Okay. Like 1 or 2 or any number that you're supposed to know. Like in this case, it'll be number 3. Okay. You're supposed to know this value. And then, well, this will be f of c. All right. Now, y2 minus y1 over x2 minus x1, right? Well, we will do it this way. Although it doesn't matter which way you do, but this is going to be nicer. F of x minus f of c, and that's why we'll put the x on the right-hand side, just to make the notation a little bit nicer. Now, just like what we had earlier, we have a limit, right? But earlier, we have h, or delta x, that's going to 0. We don't have that now. So what is the limit now? Well, we say, yeah, the slope at this point right here. So that means x is going to be very close to c. So therefore, f prime of c is this. Now, it looks similar, but different. And we call this the alternate definition of derivative, because this is representing slope of f of x at x equal to c. The earlier one is very versatile. It's a generic equation for all the slopes at any x value. But if you say, well, I know the x value and I want to know the slope at this particular x value, then I would say, oh, cool. Go ahead. You may use this. Let's see how we use this definition and get the same number at the end. Well, in this case, f prime of 3 is what we are looking for here. Limit as x goes to 3 of, and then denominator is just x minus 3, f of x minus f of 3. What is f of x? Well, that's what we had earlier, right? 2x squared plus 1. What's f of 3? 2 times 3 squared plus 1. Well, let's simplify this here in the numerator. So in the numerator, we've got ourselves 2x squared plus 1 minus what? 9 times 2 is 18. And then 18 plus 1 is 19, right? So minus 19. Keep going. Be patient. Something special is about to appear. Oops. Okay. Well, the numerator looks a little bit special because they both contain even numbers. And you see something special at this point. You can factor out x squared minus 9. And after you factor it, what's going to happen? Now, at the very beginning, you know something like this is bound to happen, because if you look at the very early notation that we had, if you actually plug in 3 into x at the very beginning, what's going to be? Well, you're going to have 0 over 0. And if you remember all the practices, all the limit questions that we did before, you are going to simplify it. You will have something to simplify. So that's why you have to be patient, work the whole thing out, and say, okay, all right. So we have 2 times x plus 3. Now you plug in the 3. So what we are saying here is this, using the this example and the previous example. If you have a function, okay, and you are trying to find the slope of a given point, okay, so you're trying to find the given slope of you want to find the slope of a given point. You basically have 2 routes. One is that you do this. That's right. You do this. F of x plus h minus f of x over h. And so you get the f prime of x equals to something. And then you get to f prime of c value. So that's one route. The other route is what we just went over, which is f prime of c equals to limit as x approaches to c of f of x minus f of c over x minus c. If you do that, you go straight to the outcome. So, and this is the analysis that you need to get ready for. All right. Are we asking you, if they don't specify what method you use, then ask yourself, are you trying to find f prime of x? Or are you trying to find out f prime of a specific x value? And then you realize that, oh, both ways will work. It's just that one, it's a bit longer, but very versatile. Like if you want to find out slope of multiple points on the function, you would definitely, you would definitely go with this route if you have multiple x values to find the slope. But if you say, no, just 1 point, then I would say, this is the best. This is the best. Now, you have to know the x value for this one. Yes, you have to. Because the c, as I explained earlier, it has to be a known value. Now, and this is where I want to chime in a little bit here on the extent of work that you will use, that you would do in this week and next week. How often we do this? Not often. Like after this unit or this section, you will never ever actually do the definitions on paper. Okay? You would not do that. However, the way the questions will be asked in the future is more like this. It's more like, let's see. Let's see if you know what's going on here. Now, this is all they would tell you. All right. So something like this. Now, some students, they would be like, oh, let me go ahead and just do the whole thing, work it out, expand it. Well, it's not going to be very fruitful, because what they expect you to know is that, do you know this is f of x plus h? If you know that's f of x plus h, can you reverse engineer the f of x? In this case, f of x is x squared. Okay? And what about this? Well, this is supposed to be f of x, right? But there's a 4 right here. Well, how come it's a 4? Because x is equal to 2, maybe. Okay? For now, let's say it's 2. So if you look at just this notation, what they are trying to say is, could you find out f prime of 2 as the answer? It would likely be a multiple choice question. It could also be f prime of -2 for that matter, because 2 or -2, they both give you 4. So this is how it transforms in the future. It goes from a very tedious kind of workout problem to something purely conceptual. So that's why you need to know, or every single student must know what these two definitions are, why these definitions are such, and every single thing, every single stroke that you're writing on the paper, you need to know why they are there. How come we use h? How come h goes to 0? How come we don't use h on the right-hand side? How come x is going to c? It all has to make perfect sense. And therefore, I would tell my students that please try your very best to draw these pictures. Because if you can draw these pictures out, you will know how to make sense of these definitions, of these notations. And I tend to believe the opposite is true. If you cannot even draw these simple pictures with notations, or with these labels, well, I'm not sure if you truly understand these definitions.